Hi, I'm Shyamala, working as Assistant Professor of Mathematics in Nalla Narasimha Reddy Education Society's group of institutions. In this video, I'm going to discuss about diagonalization of a matrix. First, we discuss about the similarity of a matrix. So, let us suppose we have two square matrices A and B of order n. Then B is said to be similar to A if there exists a non-singular matrix P of order n such that B equal to P inverse AP. It is denoted by A is similar to B. So this P is a non-singular matrix. Now, diagonalization of a matrix. Suppose we have a matrix A and A can be diagonalizable if there exists a non-singular matrix P or invertible matrix P such that P inverse AP equal to D, where D is a diagonal matrix. Then we say that A can be diagonalized as D. A can be diagonalized as D through the matrix P. So, also the matrix P is then said to diagonalize A or transform A to diagonal form. So this is a diagonalization definition. Now, when can we diagonalize and when we cannot diagonalize? If the square matrix A is having all its eigenvalues distinct, in that case, the eigenvectors corresponding to all its eigenvalues will be independent eigenvectors. In that case, A can be diagonalized. If the matrix A is having repeated eigenvalues, in that case, sometimes we may not have linearly independent eigenvectors. In the case of linearly dependent eigenvectors, we cannot diagonalize A. Now, we define modal and spectral matrices. The matrix P in P inverse AP equal to D is called modal matrix and D is called spectral matrix or diagonal matrix. Next. Using this diagonalization process, we can calculate the powers of a matrix. So means we can find A power 4, A power 6, A power 8, anything we can find by using this diagonalization process. How do we calculate the powers of a matrix? Let us consider D as P inverse AP. Then if we want D square means D into D, P inverse AP into P inverse AP. And let us remove the brackets. Then we have P inverse A, P inverse AP. P inverse A, P inverse AP. P inverse A, P inverse is identity matrix I into A into P. A into I is A into A is A square. So P inverse A square P. Now similarly, we can calculate D cube. D cube will be P inverse A cube P. And then similarly, if we go on, we will get D power n as P inverse A power n P. Now, we want A power n, that is why we will pre-multiply this equation with P and post-multiply by P inverse. That means P D power n P inverse equal to P, and these are same, P inverse A power n P into P inverse. Now, on the right hand side, if we see P inverse is I, so we have I A power n P inverse. So A power n equal to P D power n P inverse. So this is a way of calculating powers of matrix using the diagonalization process. Now we will see what is the working rule to diagonalize a matrix A and to compute A power n. So step 1 is determine the eigenvalues of the square matrix A. So first whenever we have a matrix, first we will find the eigenvalues and then its corresponding eigenvectors also we have to find. Next, step 2, find the corresponding eigenvectors and write the modal matrix. After finding the eigenvectors, we will write a matrix P, and what does that matrix P contains means all its columns will be the eigenvectors of A. So P equal to x1, x2, xn. Means these are the columns which are nothing but the eigenvectors of A. Next, we will calculate P inverse by using the formula 1 by determinant of P into adjoint of P. Then we go for the fourth step, that is find the diagonal matrix D. D means what? P inverse AP equal to B. So if we multiply these three matrices, we have to get the matrix D, that is the diagonal matrix. And what does this diagonal matrix contains means its diagonal elements are nothing but the eigenvalues of the matrix A. And how do we get the diagonal elements also means depending upon the order which we have written in the matrix P. If we are writing x1 as the first column here in matrix P, then in the diagonal matrix D also, we will have the first row element as its corresponding eigenvalue. Next, x2, suppose it is having lambda 2 as its eigenvalue, then in the second element in the second row will be lambda 2. Like that, the last element will be lambda n and its corresponding eigenvector will be xn. So, in the diagonal matrix D, it follows the order in the way the eigenvectors in the matrix P. Next, so this is the diagonalization process. Now we will compute a power n from a power n equal to p d power n p inverse. So this is a working rule to diagonalize the matrix A and also to find a power n. So whenever we want to diagonalize A means first we will find eigenvalues and then corresponding eigenvectors. Write the eigenvectors as the columns of the matrix P. Calculate P inverse. Then multiply the three matrices P inverse AP. We should get the diagonal matrix D, which contains the elements as the eigenvalues only. Next, compute a power n from a power n equal to p d power n p inverse. Okay. So, thank you.